5 years ago, we started kind of playing around with some extreme geometry on the heel and the toe. A little bit later than that, we found a way that we could actually cast a cavity into the back of the golf club that allowed it to, the vertical walls between the sole and the crown, and open this area up and move weight toward the toe and the heel. So it's a 15-year-old, a 5-year-old, and a 3-year-old idea that's just evolved as new techniques became available that allowed us to actually make this. So everybody understands the concept of cavity back forgiveness on irons, but it was not possible on metal woods until this. We also found a way to hide it all underneath the playing line, so that in the playing position you got a nice conventional looking, club. So that's the Couvert Technology, geometry hidden away.
So from the time you said, we're serious, this driver is going to happen, we are making the driver that would ultimately become the Covert, are we talking it was 3 years from commitment to launch, basically?
Actually, I never said that at all. I just kept showing prototypes to top management and Cindy Davis. I said, we could really probably have this golf club in, the year 15 or 16, and it would be, really kind of interesting for us. She said, no, I need it in 13. And so she made the commitment for me, and we basically pulled resources away from other projects, moved really quickly to try to, find a way to get this put in production and bring it to the marketplace now. So we're extremely excited about it now. That in and of itself is a technology that could stand alone on this driver, no doubt about it. At the same time, we had another top secret project that we were working on. For the last few years, we've had an off-axis adjustable system that allowed you to change the face angle and the loft and the lie of a club with our straight fit. We knew that if we could make those independent, where we could change the loft and the face angle independently.
That's actually what I wanted to talk to you about, because when we were in Orlando and you gave the presentation, I remember it vividly. One of the things you said is, if anybody wants to call BS, let's get it done.
That's it.
And now, we've heard from several of our readers that it is functionally impossible to decouple loft and face angle, and you're saying you've absolutely done just that.
Absolutely. We spent about $1 million with the top research, the company that actually ended up developing the original Xerox back, in the 60s. We've done outside independent PhDs. We work with people at Cal Poly or at Caltech. We know that by changing, it creates a very complicated mathematical problem where if you think back in trigonometry, there's a thing called a sine wave, and being able to take two different sine waves of these two 360-degree attachments that are off axis, we can line those things up in an infinite number of ways. But there's only 15 that are important to us that allow us to independently change those settings. And so what we've taken is all the different ways that you should not line this up, and we've keyed those out so that you can't put it together. So the 15 that actually are still there are moving independently of each other. So anybody wants to argue with it, we've got some PhDs that'll step up and take them on.
It's all happening in the head itself. None of this.
It's happening in the hosel itself.
Right. So when you don't need to put it on the ground and switch anything around.
No, and people that want to put them on the ground and change things that switch them around, that makes it look better on a piece of carpet when they're trying to sell the golf club. But they're also adjusting their hands in order to get the look that they want. If you think about it, Mr. Hogan, my first boss, said that you have muscle memory of the golf swing. When you put a swing on a club, your body goes back into its basic mode that it learned, and it puts the same swing plane so that you come into the golf club on that plane or into the ball on that plane of glass. It doesn't matter what it looks like on a piece of carpet. It doesn't matter what it looks like when you're hovering the club up. You're going to go back to your original swing plane. So if I cannot transform the angle of this face relative to this shaft in the swing plane where it will be, then I haven't really done anything. It doesn't matter what I do on the sole. It makes it look good in the selling, environment maybe. But if I want to change the loft of that golf club, if I can change this attachment so that in this same swing plane with this shaft locked down at impact location, if I can cock that head or have this shaft going at a more lofted area, then relative to the ball itself, it's going to launch at a higher launch angle. So that is independent adjustment of loft. The same thing happens if I want to find one of these locations that independently only changes this angle, then I've changed the face angle.
And let's talk about this cavity just a little bit more. For years, basically, since I've known anything about golf clubs and the industry, we hear year over year, well, we moved the center of gravity lower and we moved it back, and low and back, that gets us the ideal launch conditions that make this driver hit the ball farther than the one we released 6 months ago. So looking at the Covert, obviously there is no back, or certainly not low back. So how does that work? Well, with respect to sort of how everything else is supposed to work, what we've been told is ideal.
Well, for years, several years, I was one of the leading proponents. Our deep face technology moved the center of gravity back and low. That's all a really good thing for average golfers because, first, it increases the moment of inertia. The club becomes more stable. It becomes more stable both in the vertical direction and the horizontal direction. So those are all good things. But what happens when the center of gravity goes further back, it creates more gear effect for spin rate. So a deeper CG creates more backspin on drivers. For better players, that's not necessarily a good thing. But what we can do with the Couvert technology, moment of inertia keeps the club stable when hit off center, toe, and heel. Moment of inertia keeps it off stable when it hit fat and thin. So you can do that several different ways. You can toe load the weight, or you can move the center of gravity back to get those higher moment of inertias. By toe loading only and moving the center of gravity a little more forward, we're able to get the benefit of heel and toe weighted high moment of inertia, but a lower spin rate for the better player. So by moving this weight a little bit more forward, cutting this cavity in it, get these vertical walls in there, we've now got a high moment of inertia like it was if it were a back-weighted golf club. That's a good thing. But we also get an ability to reduce the spin for the better player. So those are all, it's kind of trade-out. Every golf club is a synergistic, chain with a whole bunch of different links, and it becomes one thing depending on how you treat each one of the different links. This time, instead of getting the easiest way to get a club with a high moment of inertia, we're going a harder route so that we can get a high moment of inertia with less spin.
Hey, talk about the face a little bit. One of the things our readers always say, anytime there's a new driver out, there's usually claims it's longer than our previous driver. And the argument we get back is it can't be, CT's maxed out, core's maxed out, the USGA won't let it go any farther. How are you able, and knowing that everybody in the industry is up against that limit, how are you still able to make a driver that goes farther than the one that came before it?
Well, this one goes farther for a couple of different reasons. Yes, all those people that are saying the CT and COR are maxed out, yes, check. I will agree with that. The body can still flex, and be outside of a CT check. So by stiffening the body with our cavity, we're able to loosen up some other areas up near the crown and the sole off of the face, which are outside of those tests, in order to make a little bit more rebound. The other major way that we're doing this is by reducing the spin and still launching the ball high with a higher moment of inertia. So if you launch a ball high with less spin, then you potentially can carry it further. So distance is a function of launch angle, spin rate, and ball speed. CT and COR are only about ball speed, so you have to go at this from a three-part equation. So those are the ways that we're squeezing out some extra distance.
All right, one last thing. If you're looking forward, 5 years from now, what are you doing? What is the driver look like 5 years from now? And more, I guess, we're really interested. What do you think the consumer buying experience is like 5 years ago compared to what it is today, where almost everything is off the rack?
Well, I don't believe there's any doubt that we're going to move further and further into the customization and the personalization direction for golf clubs in general. The industry needs a shot of a new material. We haven't had a new material now in quite a few years. Unfortunately, there's not a Cold War going on, so that we can take advantage of all that weaponry research that's been going on. So we're actually working on some things ourselves. So it's an exciting time. We've got a better manufacturing process for golf clubs now than any point in history. Specifications are tighter. All golf clubs are better than they've ever been, certainly in my 27 years in this industry. And so, but there's still a lot of things that we can do, and I've got
some ideas?
A couple more good years in me. I don't know what I'll do after that, but we're excited about it.
All right, Tom Stites, thanks for speaking with us.
Okay, great.